Hey guys, so in this video I'm going over Honors Math 2, Lesson 1.1, which is key features and a little bit of interval notation. So let's dive in on these key terms, remembering that if you have access to a printer, you can print these out and follow along. If not, you are writing key points of these notes so you can look back at it later. So we got quadratics. Quadratics can be described by the equation f of x equals ax squared plus bx plus c, where a does not equal 0. This graph is called a parabola. This is the graph itself. The x-intercept, or just x-int, of a graph is the point at which the graph intersects the x-axis. The y-intercept, or the y-int, of a graph is the point at which the graph intersects the y-axis. Domain of a graph is an interval of all the x values. Range of a graph is an interval of all y values. How I teach this in past years, in between D and R, which one comes first? D. In between X and Y, which one comes first in the alphabet? X. So the D and X are together. That's how you can remember which one goes with which. The y-intercept of a quadratic is the c value of the quadratic equation when written in standard form. So the first example, we have f of x equals x squared minus 2x minus 3. Remembering, when it says f of x, it's the same thing as y. Our a is whatever number is attached to our x squared. Well, there's nothing written in front of this x squared. So what could we put in front? What could we multiply x squared by and it be the same number or the same value? 1. What I'm asking is we can put 1 times x squared and it'd be the same thing as x squared. So we've got 1 out front. We've got negative 2 as our b and our negative 3 as our c. So let's find what our x and y intercepts are. I'm going to use Desmos. How you found it is going to Google. Type in Desmos. Hit the first one that shows up. Hit graphing calculator. So I'm going to type in my function y equals x squared minus 2x minus 3. So my x-axis is that left to right bolded line. And I'm going to click my graph. Gray dots show up. Those 2 dots on the x-axis is my x-intercepts. While I'm here, I also can see my y-intercept. My y-axis is that up and down or that vertical bolded line. And there, that gray dot shows me my y-intercept. So my x-intercepts are negative 1, 0, and 3, 0. And then my y-intercept is at 0, negative 3. So a rough estimate of how this graph looks, just using our intercepts, we got negative 1, 0, and 3, 0, and our y-intercept is 0, negative 3. So it looks close to this. So some more key terms. The axis of symmetry. or line of symmetry is a line through the parabola that splits it into two congruent parts. The equation to find this line of symmetry is x equals negative b over 2a. So how in the world do we get this line? So we have our A, our B, and our C. We're going to find our line of symmetry by substituting in our B and our A. So we've got x equals negative, and then we're going to substitute in our B, over 2, substituting our A in, which is 1. We're going to simplify, so on the top we get negative 2. It's looking at the wrong problem. I am so sorry. In the top we get positive 2. On the bottom we get positive 2. So our line of symmetry is found at x equals 1. Now for your vertex, you can plug in your line of symmetry for x and find y. So how you would do this is you would take your x squared minus 2 times 1 minus 3 and find that answer. Or your vertex is where the graph changes direction. So if you read this graph left to right, you start going down, you start decreasing, and then all of a sudden you change directions. You start going up instead of down. At that point, we are at 1, negative 4. That 1, negative 4 is your vertex. So your vertex is 1, negative 4. That y value is going to be negative 4. And we've already done our x and y intercept for this problem earlier. So we're just going to write them again. We've got negative 1, 0, and 3, 0. Our y-intercept was 0, negative 3. So with this new information, this vertex information, we can draw a little bit better graph of this equation. So we've got negative 1, 0, 3, 0. Our y-intercept was 0, negative 3. And our vertex, where was it? Was 1, negative 4. So it's going to be this curved U kind of shape going on. And there is your example 2. Now example 3. Let's move on to a different function. Your A is negative 2, your B is 16, and your C is negative 30. So your line of symmetry is going to be found at x equals negative b over 2a. So substituting that b in, you have positive 16 over 2, and your a is negative 2. So you have negative 16 over negative 4, which gives you 4. Your line of symmetry is equal to x equals negative 4, or x equals positive 4. Your vertex, again, you can use your axis of symmetry, substitute 4 in for x and find y, or you can look at your graph. Either way, you should have 4, 2. And then looking at the graph, it should be 3, 0. And 5, 0. Your y-intercept should be at 0, negative 30. And that is your example 3. Example 4. You're given this function. Your A is -2. Your B is -12. And your C is -10. Your axis of symmetry, so you would end up with -12 over 2, -2. You'd end up with -3. For your vertex, either you can substitute that x in and solve for y or solve for f of x, or you can use your graph, but you should get -3, 8, and your x-intercepts should be -5, 0, and -1, 0. Your y-intercept should be 0, -10. And there is your example 4. Alright, going on. And if I move too fast, please pause the video and catch up. So the direction of the opening, remembering that a parabola could look like this, a typical capital U, or it could look like this, upside down U, or a happy face versus a sad face. So when we talk about the direction of the quadratic opening, we want to know if it is opening up or down. If it is opening up, this means that the terms in front of the squared term is positive. This means y equals 2x squared. 2 is positive, so it would be a facing up or opening up. If it is opening down, this means the term is in front of the square term is negative. So y equals -2x squared. The term in front of the squared term, which is the x, it's negative, so it's going to be an upside down U. Increasing means an interval of the graph where the y values are increasing as the x values are increasing. So if you had your y-axis and your x-axis, both your x and y values are increasing at the same time, it's going upward. For decreasing, this means an interval of the graph where the y values are decreasing as the x values are increasing. So again, for example, here's your x-axis, here's your y-axis. As the y values going down, the x's are going up. So we would be going like this, going downward. Positive. Positive means an interval of the graph where the y values are positive. Negative is an interval of the graph where the y values are negative. Key thing here is that when you're talking about your positive and negative intervals, you're looking at your y values. Your maximum is when the vertex is the highest point on the graph. Your minimum, or just min, is when the vertex is the lowest point on the graph. So let's look at some of these. If you're given this graph, where is the vertex? Well, reading left to right, we're going down, 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 And at this point here, you change direction and start going up. So this vertex is located at 1, -1. Now, can we pinpoint our highest point or our lowest point? Meaning, if this graph keeps on going forever and ever and ever, even if we kept walking in that direction forever and ever and ever, could we pinpoint our highest point on the graph? No, we couldn't. We would be walking forever, and even after we pass, it still would keep going. Can we pinpoint our lowest point on the graph? Yes, our lowest point on our graph is there. So this vertex is a minimum. Orientation. Is it opening up or is it opening down? It's opening up. Now if we wanted to cut this graph in half, and if we cut it in half, I want it to be symmetric. I want both sides to equal each other. That line would go through right here, right through that vertex. So how do I show this line of symmetry? I say x equals x value it goes through, 1. Where are my x-intercepts? Well, there's one here, and there's one here. So I have 0, 0, and I have 2, 0 as my x-intercepts. For my y-intercepts, here's my y-axis, my up and down axis. Only one place does the graph cross the y-axis. It's at 0, 0. My domain, always negative infinity to positive infinity, unless we're dealing with a real world situation, aka a word problem, or if it's just a graph, some explanation that it is real world situation. For our range, smallest y value involved is at -1. And we're going to go up forever, so our biggest y value is positive infinity. So hopefully we've got that part. Now let's look at a few more parts of this graph. Increase. So we've kind of got two different sections of this graph going on, and it's split right through the middle. So which option are we increasing? Reading left to right. Are we increasing on this side, reading left to right? No, we're decreasing. Are we increasing on this side, on the right side? If we follow the line left to right? Yes. So from x is 1 to positive infinity, we are increasing. Decreasing, we are starting all the way at negative infinity, and we are decreasing until we get to 1. Now, what about positive and negative? So if you remember back to the notes, our positive and negative are focused on our y values. So whether our y values are positive or negative. So we only care about whether it's above or below our x-axis. All of our y values are positive on this side. All of our y's are negative on this side of the x-axis. So from this, we've got x is negative infinity all the way to x is 0. Is going to be y is positive. And then from x is 0 to x is 2, the y's are going to be negative. And then from, again, 2, and then keep on going forever and ever and ever to positive infinity, our y values are going to be positive. So what this means down here is where our positive intervals are is negative infinity to 0 and from 2 to positive infinity. Our only negative interval is 0 to 2. And that is how you're going to answer those. For example 7, I'm going to do I want to do 6. So pause the video and answer all of the questions for example 6. You should have gotten the following. Your vertex is at 1, 1. And it is a max. Your orientation is down. Your line of symmetry is x equals 1. Your x-intercepts are 0, 0 and 2, 0. Your y-intercept is at 0, 0. Domain always negative infinity to positive infinity. Your range, your smallest y value involved is negative infinity. And you're going to go all the way up to 1. Increasing interval is negative infinity to 1. Your decreasing interval is starting at 1 and going to positive infinity. So let's look at your positive and negative intervals. So again, it's cut by the x-axis. So on this side, we're looking at our y's are negative. So negative infinity to 0, the y's are negative. From 0 to 2, the y values are positive. And from 2 to positive infinity, our y's are negative. So when it's positive, we got 0 to 2. And when it's negative, we've got negative infinity to 0 and 2 to positive infinity. So those would be your answers for example 6. So please go through these and make sure you understand and make sure you have these written down and ready to ask questions during the live sessions. If you have any questions between now and then,